In case anyone doesn't know me, looks like most people do, but my name's Lincoln Winter. I'm the pastor at Trinity Lutheran Church up on the north end of town.
See Lincoln Winter?
Yes.
Okay.
Yeah. And of the various different Lutheran groups, the Missouri Synod is the more conservative of those. And so when it comes to the history of origins, I believe the biblical account, that is, the earth was created in 6 days, that were in fact days, as it says in Scripture. But that's not our topic. What we're actually going to look at is, and this was asked before, why this class, how evolution is taught and presented not only in schools, but in popular culture. And the reason for that is because our kids go to schools and learn this, and we exist in the popular culture. I mean, we exist in this culture. And so when you turn on TV, watch a special on History Channel or Discovery Channel, watch a news report or whatever, that's how it is covered. And even with political candidates, they always have this kind of gotcha question, you know, do you believe in evolution or creation for the origin of the world? And if someone says, well, I believe the earth was created in 6 days, all of a sudden, now, everything else that they believe becomes a non-issue, and this is now the issue. And, you know, how can you be non-scientific? And it's been proven that the earth evolved, and so on. And so the goal is to sort of respond to those arguments and hopefully give you the tools necessary to kind of evaluate what you're hearing and seeing in the culture around you. The way we're going to do this is, rather than lay out a whole bunch of philosophy, we're going to look at the system itself for today and next week, and then on the third one, we'll kind of look at the philosophical implications of it all, what this has to say about what we are believing, or what we're saying, and our origins. I'm not really going to defend the scriptural account as such. That's, again, not the purpose here. That certainly can be done. I have a bunch of books that do take that approach. And if you're really interested in it, Ken Ham of the Creation Museum, Answers in Genesis, is going to be debating Paul Nye the Science Guy on February 4th. And so that would be an opportunity to kind of hear both sides as it relates to the Genesis account.
Where will that be at?
That's going to be at the Creation Museum, I believe. They'll make that available. You can find I know they're going to make it available online and such for a nominal fee. And so people will be able to see that. What I want to do here, though, is just look at evolution on its own terms, that is, as science, or as it claims to be science. And I always like to try to give a fair shake to any idea, and I think we're going to do that for evolution, but we're going to do that by looking at it for what it claims to do and then what it needs to do. And it's probably not a surprise I'm going to find that it is wanting as scientific theory. As we do this, the first thing that always comes up when you talk to someone about this is, well, you know, you can believe what you want, and if you believe that there's a God and the earth was created in 6 days, that can be true for you. But in the case of evolution, what we're really concerned about are facts. And when we leave the church and enter the public square, we're told you need to deal in facts. And you have your religion in private, and that can be true for you. But in the world and in science, we deal in fact. This confuses fact and truth. It makes a muddle of the whole thing. Because you can't have something that is true only for you. A truth is something that is enduring and universal. It's something that does not change. In science, the term for this is law. For example, the law of gravity. Okay, what goes up must come down. In philosophy, it's called truth. For example, you shall not kill. That's not just a rule because our society arises out of a Christian context. You can go to China and the rule there is, thou shalt not kill. You can go to remote tribes in Africa, the rule is, thou shalt not kill. You can go to get in a time machine and go to Stalinist Russia, and you will find that there was a rule on the books that said, thou shalt not kill. That is a truth. Every society ever has had a no-killing rule. The ancient Greeks, the Romans, the Babylonians, whoever. But ultimately, why? Coyotes kill cattle, lions kill antelope. Why specifically is there a rule against killing people? And why is this the foundational rule, one of the foundational rules for every society that has ever been? Because it is a universal truth. It is enduring. One of the things atheists are doing these days is trying to convince people that you can have a moral code without a sacred text. Try to prove that there are universal truths, like thou shalt not kill, without having it come from above. Which is kind of an interesting thing for them to be doing, trying to prove there are, in fact, still universal truths, philosophically. A fact is merely an observation about something. You may have facts, you may not have facts. Those facts may or may not actually be true or even complete. That is to say, facts may not tell the whole story, and in fact may change. A truth cannot be changed. And societies that have tried to change that, for example, Stalin's purges in Russia, Nazis with ethnic cleansings, are reviled specifically on the point at which they depart from universal truths. A fact is merely an observation. As an example, you've probably heard the story of the 4 blind men who examine an elephant. One goes up to the leg and feels it says like a tree. The next guy feels the side and goes, it's like a wall. The third one feels the tail, says like a snake. And the fourth feels the trunk and says, it's like the branch of a willow. The point being, they all have their own impression of this. And the implication is, there's not universal truth. Well, that's not true. We may only perceive a portion of the facts, as these men do. But there is this universal truth known as elephant. Their facts are incomplete. And so we need to be careful that we have all the facts. And we need to then be careful what we do with those. Evolution claims you just take all the facts, gather them up, and combine them into this scientific law. And that scientific law is different than your personal truth. And they claim that that's the whole picture, but it's not the whole picture. Evolution says it's science, says it's based only on observable evidence of how the universe came to be. And so you have initially a hypothesis about where the universe came to be, that hypothesis then is compared to the facts at hand, that evidence is gathered, that it is then revised to match that evidence, and it is now the theory of evolution which explains all of the facts. And that's how they present it, as if somehow evolution is at its base testable. And in science the term that's used is falsifiable. That is, can you, if it's not true, prove it's wrong? The problem with evolution is that there are certain presuppositions that must be made for evolution to be true. And the evidence has to be interpreted in light of those presuppositions, and only in light of those presuppositions, and in no other way. So that even if one could interpret it to reach a different conclusion, you can't do so with evolution because it would violate the presuppositions of evolution that you've already made. We'll get to the presuppositions in a few minutes, but first, what does evolution actually explain? For evolution to be how we got here, it must successfully explain the beginning of life, that is, how you go from a universe in which there is not life at one point to, at a different point in time, a universe in which there is life. How does life itself arise? The second is the development of that life into more complex creatures. Specifically, the different species, and so it has to provide a method for speciation, is the term, and account for the differences within those species. And then there are two more that most evolutionists will either downplay as not that important or ignore entirely. But we are coming to a point where those are becoming more and more important in the discussion. And one is the development of intelligence. That is, for example, when you crack the little lid on the can, your cat knows that that means it's feeding time and immediately rushes to your feet. Okay, the cat has learned this. Hears that, interprets it, and then knows to come to where you are to be underfoot to get the food. That takes intelligence. As opposed to a bacteria that just sort of wanders around hoping food shows up. And then the fifth thing is it has to explain the development of consciousness. A cat has a certain level of intelligence but does not have consciousness, the ability to reflect on self. The cat does not sit around thinking, I am a cat. How did I, as a cat, get here? That's something that is unique to humanity. Now, evolutionists would claim that that's simply an extra level of intelligence, a higher level of intelligence. But there's no evidence that that is in fact true. My smartphone has a very high level of intelligence. It can find things on maps like that and then tell me how to get there. but it cannot reflect upon itself. Like I said, the evolutionist, the materialist will discount these as simply arising out of material things, but there's no specific reason why the neurons in the brain forming together should in fact allow for intelligence and specifically consciousness. And so evolution needs to explain those. And it's becoming more of an issue as we move from an information age into an age where computers are, again, more and more intelligent. So much so that there's a book by an atheist philosopher. I have all those books, and I didn't bring that one with me. Called Mind and Cosmos, where he examines the idea of intelligence and consciousness and says this cannot arise naturally and randomly. And he pegs it as different than simply explainable by firing neurons in the brain. A parable about a teddy bear. And just so that my daughter doesn't get mad at me, this is not autobiographical. Let's suppose you're the parent of a young child and you walk into the kitchen to discover chocolate sauce spread everywhere.
What are you going to do?
All over the kitchen. Not autobiographical. And so you call your child over and say, "What happened here?" And your child, dragging beloved teddy bear behind him, says, "Teddy did it." Teddy bear did it. That's how evolutionists see creationists. We look at the evidence and we say, the teddy bear did it. In this case, the teddy bear being God. So from their perspective, we are simply discounting the evidence as they see it. But we can also turn that analogy around. Let's suppose that now, rather than the creationist being the small child, the evolutionist is the small child. And you say, what happened? Teddy did it, and we'll discuss later. We'll come to see what Teddy is in this scenario. The usual Christian response to this, too often, I believe, is we say something along the lines of, but look, Teddy is not covered in chocolate and you are. How could Teddy have done it? And then the child says, no, but look, Teddy's paws are dirty. And you say, but that's from last week when Teddy was out in the sandbox with you. That's not from the chocolate. And now you're in an argument with a 3-year-old about how Teddy's paws got dirty. An argument which, before it began, you have already lost. For the simple reason that you're arguing about the wrong thing. And you're allowing too many assumptions to go untested. You're now arguing about the evidence on Teddy's paws, rather than arguing over whether Teddy is in fact able to have done the thing that it is claimed Teddy did. For example, is Teddy able to go into the kitchen, grab a bottle of chocolate sauce, and spread it around the kitchen? Teddy has not the intellect to do it. He has not the motor skills to do it. He cannot form the intent to do this. So we can discount Teddy as a source before we get into an argument about his paws. For the evolutionist, they look at this and would say, we're assuming that Teddy, that is God, is alive and he is not. That's how they see it, and we need to understand that. That's going to be important later when we talk about some other ideas. As I see things, quite often we get into debates about radiocarbon dating or radiometric dating of rocks and things, feathers on birds, the development of humanoid development, those sorts of questions. These are all evidential questions that are important in their place, but I think to some extent it's arguing over Teddy's paws. And now a second analogy, because that's similar and will make a similar point, but we're going to use it in different ways later on. If you have a house built, you get a builder lined up to build a house. You pick a plan, and then the builder goes to work building it. And at some point, you need to pick the paint color. Now, you may have it all picked even before he begins, but you may change that as time goes on. Until paint is slapped on walls. Very late in the house building process, you can change your paint colors. You don't really need to discuss with the builder how to build the stud walls, how to do the foundation and such. The builder will take care of all those details. And I fear too often in debates about evolution, we get stuck on paint color and fixtures, which are very important in their place, rather than the fundamentals of the structure itself. That is to say, whether life could have evolved from the building blocks life needed to evolve to into the structure known as life. There are a lot of steps in this process that have to happen. And if we find that evolution can't do those early steps, then arguing about, whether dinosaurs had feathers, how birds got feathers, this is final product. Are cells possible? That's a fundamental question that's often glossed over. And so, the question is, can evolution build the house itself? Again, obviously, come as no surprise, I'm going to say no. But the reason for that is the fundamental presuppositions of evolution are contrary to the evidence. Now, the evolutionist says, we're merely dealing in the facts. But the dirty secret of evolution is it's no more founded on facts than any other method of origins. It really isn't. There are fundamental presuppositions that must be true in order for evolution to work. And those fundamental presuppositions can't be tested or examined. There's two of them. One can't be tested at all. It must be assumed. The other is assumed contrary to evidence that we do have. So the evolution of evolution. How did we get to this process of life being here? We're going to go back to Darwin for a little bit and look at what Darwin taught. And there's a lot that goes on before him, but this is how it is usually presented. We start pretty much with Darwin. Darwin is a product of the Industrial Revolution. That's very important to understand. Because the Industrial Revolution understands things mechanistically, according to the mechanical function that it fulfills. And there is no better example than the development of the steam engine. It is what drives the Industrial Revolution. It's invented in the late 1700s as originally to pump water. And the basic steam engine is you have a piston in a cylinder. Steam is forced into the cylinder, pushes the piston up because of higher pressure, which then runs a pump. Now, the original steam engine was not very efficient. It was more efficient than a hand pump, but not by a lot. You would push the steam in, then you would have to pour cold water on the outside of it to condense the steam, to cool and condense the steam inside, which would then pull the piston back down. Eventually, someone figures out Well, wait a minute. We could, rather than having to pour water on it, have a second valve that opens at the right time to let the steam back out. And rather than have this directly drive the pump, we could put a flywheel on this so it gets spinning round and round, and it will drive the piston back to position 1, wherein the steam will then go in again. It's not important to understand all of the mechanics of a steam engine, so if you're not getting exactly how it works, that's fine. But just understand the development of the steam engine itself as concept. Now, in addition to this, steam engines start getting so efficient and they're running so fast that they're going faster than the metal itself can handle structurally, and they start blowing apart. So someone realizes they need to have a way to slow it down if it gets too fast. So they develop, run off the same thing, a governor, and it's basically two balls that when it that spin around, and the faster they spin, the more they come out. And the more they come out, the more they close the steam valve. So the faster the steam engine goes, the more the steam valve gets closed down, which then prevents it from going so fast that it blows itself apart. Someone figures out that, hey, if we turn this flywheel sideways and put it on a track, the flywheel, as it spins, will pull a vehicle. Trains are invented. All of this arises from the steam engine. Okay, Darwin lives in this industrial steam engine age. And every one of these things I've discussed is kind of a natural development from the basic concept. And mechanistically just kind of makes sense. You say, hey, it could do it this way. We could add this. It would make it a little more efficient. And so the steam engine develops. At the same time, Darwin is developing his theory of evolution. And Darwin's theories, especially, for example, Origin of Species, looks at the function, the mechanics of living things. And there's the big example used in evolution to say, look, evolution happens, is the peppered moth in England. If you've ever had evolution taught to you, you've for sure heard of the peppered moth. The peppered moth is a little moth that used to be not very good at drawing animals or anything else, but used to be mostly white with some black spots, hence peppered moth. The Industrial Revolution comes along. They're burning coal like mad in England. Everything turns black. All the buildings are coated in coal. They're even today, you go to Europe and London especially, you can see sometimes there will be buildings that are being cleaned of this coal gunk from the Industrial Revolution. And so the problem is that a white moth with dark spots is now going to stick out like a sore thumb on all of this black gunk that is coating everything. And so the peppered moth during the time of the Industrial Revolution evolves so that it is mostly black, with few, if any, white spots. Ta-da, proof of evolution, right? This is a matter of function. And it fits in well with what Darwin had to say about the different functions of the different parts of animals. So, for example, if we look at a woodpecker, it has a long beak and a very hard head to facilitate smashing its head repeatedly into trees. The head on the woodpecker, the skull on the woodpecker is so hard that, in fact, scientists have studied it when they make football helmets to figure out how to reduce the impact on the brain. That's how effective woodpecker skulls are. Now, Darwin would say that this arose according to the function of needing a harder skull, a longer beak to get the bugs out of the trees. A third example, the panda bear. It has what appears to be 6 fingers. But it turns out it's not actually 6 fingers. It's 5 fingers, and then right here, there's kind of a thumb pad. If you've seen dogs or cats, they have kind of pads on their paws. It's got a little pad there, and it's got this little bone that sticks out that can be used to help it grip bamboo. Now, when you actually look at where this bone came from, it's actually a small wrist bone that is greatly enlarged, and only on the panda, not in other bears. That helps the panda to grip this. Now, according to Darwin's theory, you would have slowly had the development of this bone that gave this panda an advantage over other pandas, or as pandas came into being, gave it an advantage in eating bamboo over other animals because it made it easier to grip the bamboo. And therefore, this became the dominant and eventually only form of panda. It was simply a random mutation that helped this particular panda evolve into a bamboo-eating machine, giving them an advantage that then took over. With all of this, we need to make a distinction in the 2 kinds of evolution. One kind which does exist, and one kind which really doesn't. And the 2 are microevolution and macroevolution. For example, Saint Bernard, Chihuahua, or Australian Shepherd, or any of the other herding dogs. They have been bred to herd. St. Bernards have been bred to be big. Chihuahuas have been bred to be small. They are different breeds. The classic example, the argument has been going on over for a number of years in this area, is the Preble's Meadow jumping mouse. Some of you may have heard of that. It's different than the other jumping mouses because it is ever so slightly different. According to the Endangered Species Act, which now has all sorts of rules about what you can do with land wherein the Preble's Meadow jumping mouse may exist. But we need to make a distinction here between species, because evolution says this is origin of species, and genus. The Latin word species actually means appearance or quality of something. And a species, scientifically, is defined as groups that do mate with each other. So, for example, if you have a bunch of trout that live here and a bunch of trout that live here, just a couple of feet lower in the strata of your lake, they don't intermingle, they don't mate, those are different species. They could intermingle, theoretically. So a Preble's meadow jumping mouse could intermingle with a regular jumping mouse, but of course they don't because they're only found on land in this area and so on. That's distinct species falls under microevolution. So you can have different kinds of cats. For example, you can actually, I just found out, interbreed a lion and a tiger, called a liger. I don't care what you call it, I don't want to meet it in a dark alley. They can successfully interbreed. Macroevolution deals with different genera, or singular genus, which is the Latin word for kind. And Scripture speaks of this. Each animal according to its kind. A genus, or in scriptural speak, a kind, is something that can fruitfully reproduce. For example, horse, donkey can interbreed. It's a mule. It's sterile. Can no longer reproduce after that. So while a horse and a donkey can interbreed, they cannot fruitfully reproduce. Because they're very close to each other genetically, they can have an offspring, but that offspring cannot then have another offspring. However, you could take a Preble's meadow jumping mouse and a regular jumping mouse, and they could successfully interbreed, and their offspring could then also successfully interbreed. They are from the same genus. And so from what we'd say is a scriptural perspective, where it speaks of kind, that being fruitful, if you have a mouse that can mate with other mice, it's a mouse. Very simple. It may have over time developed certain characteristics, much like, for example, people from Northern Europe generally have blonde hair. People from Southern Europe have dark hair. They're not different species. They have different characteristics. But if you were talking about mice under the same circumstances, for the Endangered Species Act purposes, those would be separate species. They live in separate zones, they have separate characteristics. And yet it is the same genus. That is, they could successfully and fruitfully reproduce. So with all of that as background, we get now to the two fundamental presuppositions without which evolution cannot be true. Presupposition number one, there is no God. Right off the bat, that must be accepted. And no matter what evidence you find, it must be interpreted in a way that disallows God. This is not a testable hypothesis. Unless God were to reveal himself, we cannot know whether there is or is not a God. And from the perspective of the evolutionist, I think we'll talk about this on week 3, you can never have enough evidence that the evidence for there being a God will never be enough. Because we've already presupposed there is not. The theist says there is a God. These are fundamental presuppositions. You can look at all the evidence you want, but your evidence is going to be interpreted in light of this, one way or another. You have to simply accept one or the other position and then move on from there. Presupposition, this is why I say evolution is a religion, by the way. Because presupposition number one has to do with God. They would, of course, argue. No, we're saying that it's evidence and we're excluding God from the equation, to which I would say, exactly. It's something having to do with God, and you are automatically, in philosophy, it's called an a priori assumption, something that must be true before anything else. You are automatically excluding him. That's a theological position. A position regarding God. Especially when we look at presupposition number 2, that must... That's a terrible 2. Try again. That must be correct as well. Randomness can appear ordered. If randomness cannot appear ordered, evolution also falls. According to evolution, all of the order we see in the universe arose randomly. In fact, Richard Dawkins, noted atheist, and also his background is in biology, although in recent years he's gotten farther away from that. His earlier work has more to do with biology, sort of. Says this: biology is the study of complicated things that give the appearance of having been designed for a purpose. Now, Darwin does not account for order in his theories, for the simple reason that mechanistically it seems less important. From a purely functional standpoint, you can introduce hypothetical mutations to a steam engine or a panda or a woodpecker that improve function. But the problem with this that arises in the 20th century as we leave the industrial age and enter the information age, that's also the point at which it's discovered that at its base, life is information. This is a problem, a very big problem. Because Darwin's theories cannot work at the level of information. They only explain function, not information. There's a difference between them. And when you move into information, in fact, the odds of evolution suddenly become so remote that until recently, statisticians were never heard in this debate. That is to say, the statistical likelihood of this happening. Recently, statisticians weighed in on a very specific point we'll get to in session 3. See, I tease with these things so you come back. In Darwin's day, it was assumed that cells were basically just blobs of plasm. It wasn't assumed there was anything to them. Now, as microscopes improve, scientific evidence gathering improves, we discover something that is a very big problem, again, for Darwin, and that is that cells have a structure inside of them that is very organized and very information-driven. And this is the great discovery of the 20th century from a biological perspective, and you've probably all heard of this, and that is DNA. The study of genetics, begun in the very late 1800s, leads eventually to the unraveling of DNA in the 1950s, and they discover that DNA is, in fact, structured in a double helix. We're going to talk about DNA as a structure next week. But Crick and Watson get the Nobel Prize for that. It has two, just in brief, you have what's called the backbone, that's, again, a double helix twisted. And in there you have adenine, thymine, guanine, there we go, didn't want to mispronounce it, and cytosine. And these four things, these four amino acids, pair up in very specific ways that's basically like computer code for your cells. And when we look at information and its ability to arise randomly, we run into a lot of problems. And so now we're going to leave DNA for the rest of today and enter into the realm of information. Because unless evolution can explain how information arises, it's dead in the water before it even begins. And the only explanation I've heard of how information can arise, is from Richard Dawkins, noted atheist and biologist. And his theory to me sounded so, he's a very smart man, I hate to use the word stupid, foolish, short-sighted, that I couldn't believe there wasn't a better idea out there. And so I looked as much as I could and finally came to the conclusion that apparently there isn't. And it's an idea that's 30 years old. He came up with it for a book called The Blind Watchmaker back in the 80s. And I thought someone would have come up with a better idea by now, for sure. But I go through book after book and haven't been able to find it, if it's out there. And that is, if we take a phrase, and the phrase he takes is the Shakespeare phrase, methinks, space, it, space, is, space, like, space, a, space, weasel. I think he picked this phrase to kind of poke at creationists, but whatever. The phrase I prefer is, "O mistress mine, where are you roaming?" But we'll go with his phrase that kind of pokes at us. We can work with this. There are, including spaces, 29 spots for information. Each spot has a certain bit of information. An M, an E, a T, an H. And in each one of these spots, because you have 26 letters plus the space, you have 27 possibilities for what it could be. Now, to come up with this phrase, you can't just add 27 plus 27 to try and figure the odds. You have to multiply, because the M could be an A, or a B, or a C, or a D, and so on. If the M is an A, this could be an A, a B, a C, a D. If the M is a B, this could be an A, a B, a C, a D, and so on. Okay, so you see, as you get more information, you're multiplying to get the odds up. So there are 27 possibilities, don't forget the space, here, times 27 possibilities here. Just to get me is a 1 in 729 chance. There's 729 possible combinations of just these two letters. By the end of this word, you're in the billions. And so, thanks to Microsoft Excel, I was able to find out how many possible combinations there are in this large phrase. There are 11 duodecillion, 972 undecillion, 515 decillion, 182 nonillion, 562 octillion possibilities. After that 562, there are 27 zeros, in case you were wondering. Now, to give you an idea how big this is, how big a number this is, the newest Chinese supercomputer, I looked it up, can do almost 34 quadrillion floating point operations per second. And if we assumed every one of those was a new combination of all these letters, which is not actually what a floating point operation is, but if you had 34 quadrillion tries every second, and you started at what evolutionists say is the beginning of the universe, 13.82 billion years ago, for a total of 473 trillion seconds. And you tried 34 quadrillion combinations a second for 473 trillion seconds, it would take you 747 million of these Chinese supercomputers to come up with every possible combination here between the beginning of the universe, 13.82 billion years ago allegedly, and now. Which is to say, information is very complicated. Now Dawkins says, you're doing it wrong. When we look at information in the cell, or information that arises in evolution, we're not starting over every time. We're building on what was there before. And so, this is back in the 80s, he develops a computer program to test his theory. Rather than just randomly trying one, throwing it out, and trying again. We will randomly come up with something, and then we will use that and randomly mutate it and have the computer pick the best option that's closest to what we're trying to get to. And then we will do it again, and again, and again. And how many generations, then, does it take to get from random, which I'm not sure if you can see it, WDLT, MNLT, this is what his computer randomly came up with, space, DTJ, BK, WIRZ, REZ, LMQ, CO, space P. That's what it comes up with on the first try. One or two of the letters is likely going to be correct. And so we then have a random chance of a mutation. The computer compares the two to see which one is closer to, methinks it is like a weasel. And on the second generation, we have an S in the correct place added. By generation 30, we have methinks it is like Wexel, which is getting closer. And after 43 generations, we get methinks it is like a weasel. He runs his computer program a second time, he gets 61 generations. A third time, he gets 41 generations. And so, somewhere between 40 and 65 generational mutations can get you to this. His point is, see, information can arise randomly. But there are two huge problems with this that Dawkins does not address. Well, one he doesn't address at all, and the other he claims to address but doesn't. And I'll explain the problems, but how he tries to address problem two we'll have to wait till next week. The first problem, the problem you cannot get past from a life perspective, is that generations 1 through 42 are not actually information. By generation 20 or 30, you're getting near to, but it's still not correct. Back in the 80s, when personal computers came out and programs were small, we would get magazines that would have computer programs in them that you could type into your computer and then play games. So we would type this program in, it would be 2 or 3 pages. And of course it's all computer talk. You don't know what it's doing, you're just typing. And you get done, I finally got it, hours and hours later. Press run, and you press run and it does nothing. Okay, go back. Check every single letter that you entered. Make sure it's correct. And after about a half hour, 40 minutes, I found a 0 that's supposed to be a 1. Okay, we changed that. You run it again, it still doesn't run. Okay, got closer. So you keep going until you find every single error. And sometimes this could take 3 or 4 go-throughs of the whole program to get all of the errors. And finally, your program would run. The point being, when you're looking at information, it doesn't work if it's not actually information. This is not information. Is not information. It's simply not. And from a genetic perspective, when you get the information wrong, and we'll talk about this more next week again, it doesn't do it. It doesn't work. That's genetic mutation that's bad. Okay, the royal families of Europe were all beset by hemophilia because there was a lot of intermarriage, and once you got that genetic mutation into the royal family and you're all marrying your cousins, that's why you can't marry your cousins today, you've got a problem. And so it almost ends up, by the time you get out of that royal period in Europe, that more people had hemophilia than didn't, it seems. It was a very common thing to have. Most families had at least one person with it. And that was one genetic marker all of a sudden being out of whack. This won't do anything. This phrase does something. Up here, generation 1 doesn't do anything. You cannot have non-information exchangeable with information. They're not exchangeable on a one-to-one basis. You cannot have non-functional suddenly become functional from a life perspective, because it has to do all the things needed to get to life. Which is to say, you need information to get information. For this to work, the way Dawkins says that you eventually arise at this, you would need in generation 1 to come up with a 29-letter phrase that is actually a phrase, that may not be this phrase, but is a different phrase. And then in each succeeding generation, have a single mutation that is also effective information until you arrive at the final bit of information. This is not information. It's not functional. The second problem, and this is actually the more serious one, although it may not seem so at first, is you're inputting information you're inputting where you want to end up and then arriving there. And as Dawkins himself will admit, and claims absolutely is the truth, evolution is undirected. He does admit this and says that there is a solution to this, and we'll look at that next week and see how that fails. But when you start with information and then try to arrive there, that's called teleology. It's the study of what's going to happen at the end, directing what I do now. As an example, when you go on vacation, you go on vacation because of what came before. Where you end up is because of what happened previously, when you went online, made the reservations, bought the tickets, decided where you were going to go, all of the things. Okay, I'm going to Disney World this year, I'm going to Europe, I'm going on a cruise, whatever it is. You make these decisions and then go on vacation. Even if you say, I'm just going to randomly backpack through Europe, you've already made a number of decisions. Socioeconomically, geographically, decisions have already been made. The only way to randomly do a vacation is to put every city in the world into a hat, draw one out, and go there. And when you get there, put all of the hotels into a hat, draw one out, and stay there. That's not how it works. A vacation exists because of all the things that came before. And when you say, look, this arose randomly, but it arose randomly because the computer told it to get here, you've picked your destination before you began. Evolution is, so they say, without destination in mind. Once you pick a destination, that's a totally different kind of vacation. They're not even remotely the same. And so Dawkins ruined it by having a goal. And he does admit that. Give him credit where it is due. Very rarely. But number one, he doesn't understand how big a problem it is. And number two, and this is what we'll pick up with next week, is he does it in a way that has the exact same problem. But I promised everyone not a minute more than an hour. It's exactly 7:30. So, thank you very much.
I don't see any dancers.
There are no dancers. There are no dancers. What? Oh.
As they keep going.
They haven't evolved yet. It won't be the next week.
What's that?
The dancers haven't evolved yet.
I guess they won't know. I was told there would be dancers at 7:30, so I needed to keep it on an hour. Okay. Who needs to get up and move around and cannot keep going for another 5 or 10 minutes?
Go for it.
I'm gonna ignore. Okay. Okay. Well, we can stand up. You can stand up if you need to.
We're gonna have a stand-up.
Okay. I guess we'll stand up. I'll finish up with Dawkins' second program, and then we'll be done. So we can have finished with Dawkins' brilliant attempt that again is quoted in this book and this book and this book. I haven't read that one yet, but look, he's solved the problem of information in evolution. And so Dawkins says, we have an end in mind, and that's kind of a minor problem. So I write a program. I'm going to write another program that will solve for it. And this program randomly makes shapes. It starts with a little line, and then by a series of random mutations can add, either make a line longer or shorter, or add to the line with another line. Now, because of the limitations of computers in the 1980s, he makes it a mirror image. While I think that's cheating, because a mirror image is far more likely to look like life than not a mirror image, computing in the 80s is fairly primitive compared to today. We'll let that fly. We'll let that one slide. But so if it goes there, it arises. You're going to have a piece there. The next time, these lines could grow, shrink, or have another line added. Okay? Kind of follow the principle, hopefully. It will randomly produce a few variations. He will then function in the role of natural selection, pick a winner, and then have that one evolve. So from here, maybe the next one has short little legs there, or has an extra arm here, or, I don't know, has a really short, is really short there. Okay, you see? And he will pick which of these three then goes on, is the winner of this round, and beats and is the improvement that natural selection chooses. The others die out by natural selection. Okay. And he's just going to go see what happens. Well, after a few generations, he says, it begins to look like an insect. Kind of, sort of, like an insect. And so, he continues this program, very excited. He writes this very breathlessly. Like this is his great epiphany moment wherein he saw the light. Each generation he picks the most insect-like until he gets one that looks very, very much like an insect. He's extremely excited. He's breathless, according to the way he writes it. Wow, this is amazing. Look at how random mutation produced an insect. Therefore, it is possible for randomness that is undirected to get somewhere. A couple of problems with this experiment. One, he's looking merely at form, not function. So none of these has any information because they're kind of Rorschach tests. That is, you're given an ink blot and you decide what it looks like. And it looked a great deal like an insect. I'm not sure I could identify what insect. It looked kind of like an insect, but I never saw one that looked just like it. And so, it's not actually information in that sense. It's merely a picture. Another problem is, there's still an intelligence behind the winner being picked. Evolution says there is no intelligence behind this. It's mere chance and whatever is most fit to survive in the circumstances. So if you had giraffes that suddenly evolved with very short necks, they would not survive because they couldn't eat the leaves. They couldn't reach them, and so they would die out. In this case, though, there's an intelligence behind it. That's huge because that's the one thing they refuse, they say cannot be behind evolution, is an intelligence. The other really big problem with this is he gets very excited when it begins looking like an insect, and in each generation chooses the most insect-like among them to progress to the next generation. Same problem we had in the previous example. There's an end in sight, and that is the insect, which is most insect-like. In the case of evolution, there's no intelligence behind it. There's no end in sight, so they say. Here we have both of those things being true. And so the point of all this is that Dawkins has given no model for information to arise. Not in any sense for information to randomly arise, for order to arise out of disorder. And as I mentioned before, Dawkins was written some 30 years ago. No better model has been proposed that I'm aware of. That is, again, a philosophical thing that must be proposed. It's not, you cannot have that based on evidence because we're looking at the very earliest bits of life. Information originally arising from disorder. We're not talking about the difference between gorillas and people. We're talking about the difference between a single cell and this water. This is very, very early stuff that evolution cannot account for and has given no model for how it could even potentially arise in a realistic way. And the atheists all say, well, Dawkins already answered this, so we don't need to address this. But he didn't address it at all. He proved that if you have an intelligence behind things, you can have information. But I think that's what we were saying this whole time. Dawkins says nothing about undirected natural selection with no goal in sight, driven only by random mutations, being able to arise to the level of information. And that is what is necessary. So that's the end of the section on Dawkins. We're going to look at this again in the context of DNA next week.